In this lesson, we're going to be looking at percentages. More specifically, we're going to be calculating percentage change. But before we head into that, it's really important that we all understand how to actually use percentages. So to start off with, I've got a picture of your calculator you use in class, and we've got the simple question of having to calculate a percentage of a quantity. So just ignore these numbers on here, it's the best picture I could find, and we've got the question here to calculate 50% of 120. Now most of us could probably do that without using a calculator because we know that 50% is a half. So I've used this simple example so that we can all see what answer we should expect at the end of this calculation to see that each of these three methods I've got hidden behind these boxes work. So three methods are sitting here. One is one way that a lot of you would use percentages and work out percentage quantity. Another one is for a small majority of people. And the last one is more of a weird way that I sort of look at things, and I find it easier, so I don't want to cut anyone off from this easy method. I'm going to have a look at all three, and you can pick which way you want to use. So to start off with, method one, we've got the 50 over 100. So whenever we're dealing with percentages, we've got to remember to divide by 100. So we go 50 divide 100 times 120. Which is the quantity, and that gives us 60. That's the straight up we're working out 50% of 120. And that's the way a lot of us would be used to. There's a second method where you can use the actual percentage button on your calculator. So if I pull out my little circles here, you'll see, and it's a little hard to see on this picture of a calculator here, but above the 1 you've got a yellow percentage sign. So if you go 120 times 50, second function 1 to get that percentage up, and note you don't press the equals button when you do this. The calculator will automatically work out the answer and give you 60. So to do percentages on your calculator, really easy to do. Second function 1, that gives you the percentage. Now also note the order that I've got this. If you do 50 times 120 and then do the second function 1, you're actually going to be working out 120% of 50, which is not going to get you the same thing. So you need to put the quantity in first and then multiply it by the percentage. Alright, the last method is one that I use, and it involves adjusting the percent before you use it. So I need 50% of 120, which means I am getting rid of 50%, so I'm keeping 50%. The original quantity is always 100%. I get rid of 50 of it because I only want to keep 50. I divide 100 because I'm dealing with percentages, and then I multiply by 120, which is the quantity. Now, it seems a little difficult in this stage, but when you get to questions how it asks an item has a discount of 10%, it means I only have to just work out 90% of that quantity, and that tells me the answer straight away, rather than this way of working out 10% of the quantity and then taking it away from the answer. So it looks a little more complicated here, but it does have its merits. Let's go and have a look at those. So now I want to have a look at percentage change and the idea behind this lesson. And percentage change is simply increasing or decreasing a quantity by a given percentage. And here's a little extract from your textbook, and it's using the method that I like to use. So if you need to increase a certain percentage, you add the percentage on to 100%, and then you multiply by that new percentage. If you need to take it away, you get rid of that percentage from 100%, and then you multiply that by the quantity. So let's have a look at a few examples to explain this. I've put the extract up top so we can keep referring to it, but let's have a look here. Harvey Norman, they buy a toaster for $36, and they need to put at least a 5% markup on the toaster so they can sell it for a profit. So what we're talking about here is the cost price of the item is 36%, so we're going to add that in, and we're going to use the term cost price. So cost price is talking about the original $36, and they're required to put a 5% markup on it so they can sell it for a profit, which means the sale price is going to be the $36 plus the 5%. Alright, I'll just bring that back. So method 1, using my way, is to add the 5% to an original 100%. So we're actually got to work out what 105% of this item is worth. So $36, if we work out 105%, that includes the original amount and the 5% markup that it's got. So to calculate that, you do 105% over 100. Remember, when we're dealing with numbers and percentages, we need to divide the percentage by 100, multiply that by 36, and gets us $37.80. Method 2, or the way that a lot of you would do it as it stands now, involves working out 5% of 36 and then adding that on to the original price separately. So calculating 5% means we do 5 over 100 times 36, and that gets us our $1.80, and then we get our $1.80 and add that 5% value onto our original price to get $37.80. So you can see that the working out using this first method here is much shorter. It's really easy to do 100 plus 5 in our head and then use that calculation straight away, rather than working out 5% of the item and then adding it on. So that's just food for thought, but a lot of you would be more comfortable doing it with method 2, and a lot of you would have been using method 2 for a long time in your math. I just find this one shorter, easier, and less time wasting in an exam, which is what we're aiming for. So up to you to pick which one you want to do. Okay, so that's our first example, and that was an increase. So we obviously added percentages on, so we needed to add 5% to the original, or we added the $1.80, which is the 5% value on. If we had a percentage decrease question, we would be taking the 5% away, or we would be working out 5% of it and then taking it away from the original value. So not much changes when we've got a percentage decrease. We just change adding to taking away. In this more complicated example, you're going to be asked to deal with repeated percentage discounts or percentage change, so either a discount or a markup. So here JB buys a set of computer speakers for $75. When shops buy items, they need to put a markup on it so they can actually make profit. And so JB here, they mark up everything they buy by 20%. But then JB have this store-wide discount of 20%. And it's going to be interesting to note here that just because you start with an original price, you mark it up by 20%, and then discount it by 20%, it doesn't mean you go straight back to your price. The way percentages work is it's based on the original value you started with. So marking up something 20% of 75 is a certain value, but once it's increased and you have the new value, 20% of that new bigger value is going to be more than 20% of 75. So I know it probably sounds a little confusing now, but we're going to have a look at it and prove my point. So we've got to calculate the sale price first, remembering that $75 is the cost price, and once you put a markup on it, that's the sale price. So using my method, the sort of weird one is I have 100% of the price and I'm increasing it by 20%. So I actually need to work out 120% of the cost price. 120 divided 100 is the 1.2, times it by $75, and now JB is charging $90 for the set of computer speakers. Once we do that, they've been sitting on the shelf for a while at $90, they're not selling, and JB are having their store-wide sale of 20%. We need to calculate the 20% decrease. So we're starting with 100% of our original value, the $90, and we're taking away 20%. So it's only going to be worth 80% of what it used to be worth. Doing that, as you can see, we've got the 80%, we've divided by 100, so it's 0.8, we're multiplying that by 90, so the final price actually ends up being $72, which is less than the original 75. And that's because 20% of 75 only worked out to be $15. But 20% of the new larger price of $90 worked out to be $18. So it was slightly bigger, which means that the discount is going to be a bigger value. And it also, this example here is to explain repeated percentage change, in that you need to do each change. So if it's an increase and then a decrease, you need to calculate the increase and then calculate the decrease with your new answer. You can't simply just adjust the percentages by going plus 20, minus 20, therefore no change, cancel out, and the price stays at 75. Because as you can see here, it changes. Okay, Last example is for the students intending to do General 2 next year. It gets a little harder, and it's a little backwards to what we've just been doing. So we're actually going to calculate the percentage value when we're given quantities rather than calculate the quantity of a percentage change. So here we have the price of a video game was decreased from the original sale price of $90 to $81, and we actually have to calculate the percentage value of this change. So we're going to work out what kind of discount this game was given. So first off, we need the straight up difference. It was $90, it's now $81, therefore the difference is $9 in price. Once we've got that, we get our $9 and we divide it by the original price. And it's always, and I've underlined it there, you always divide it by the original price. We're doing a decrease. If this was an increase, you still divide it by the original first price that the item used to be. So we got 9 divided by 90 times 100, and it leaves us with 10%. So we put that in words, and we say that the video game had a 10% discount applied. And that's all there is to percentages that we need to know at this stage. So we've got basic percentage change, we've got repeated change, and that we need to do each step separately, and then use the new answer to keep doing the percentage change, because that does actually alter our answer. And our last example was just looking at doing the working out backwards a little bit, and we've been given 2 quantities and we're asked to work out the actual percentage value of the difference between those. Alright, so thanks very much for your time, and I'll see you in the lesson.